Hi, good morning, our students. Our lesson today is the set of irrational number Q dash. We remember that the rational number is any number we can form it or write it in the form of A over B, where A and B belong to Z, or A and B are integers, and B not equal to 0. Why B not equal to 0? Because A over 0 has no meaning, it's meaningless. So B must be not equal to 0. And this set of rational numbers is denoted by Q. So all integers, decimal, percentage, square root of perfect square number, and cube root of perfect cube number are rational numbers. Why rational numbers? For another time, we can write it in form of A over B. What is the perfect square numbers and perfect cube numbers? Perfect square numbers is a number results of any number for power 2. 1 power 2 equal 1. 2 power 2 equal 4. 3 power 2 equal 9. 4 power 2 equal 16. 5 power 2 equal 25, and so on. These numbers are called perfect square numbers. Perfect cube numbers, any number we can get it from power 3. 1 power 3 equal 1. 2 power 3 equal 8. 3 power 3 equal 27. 4 power 3 equal 64. 5 power 3 equal 125, and so on. These numbers are perfect cube numbers. But square root of 2, it's a rational number. You can write square root of 2, the result of square root of 2, as A over B. No, we can't write it as A over B. So square root of 2, it's not a rational number or doesn't belong to Q, because there is no rational number whose square is 2. This number, I don't have any number with power 2 to give me 2. So we can't write square root 2 in the form of A over B. For example, 5, it's an integer. We can write it 5 over 5. Then it's belong to Q. Negative 0.7. We can write it negative 7 over 10. It also belongs to Q. 0. It's an integer. 0 over 1 belongs to Q. Cube root of 10. We don't have any number with power 3 to give me 10. Then cube root of 10 doesn't belong to Q. So it's belong to Q dash. What is a Q dash? It's the set of irrational number. The set of irrational number. Pi doesn't belong to Q because it's approximated ratio, not exact ratio. So pi belongs to Q dash. Cube root of 8. Cube root of 8 equal 2. So it's belong to Q. So Q intersect Q dash equal 5 because Q and Q dash are disjoint sets. Disjoint sets. The irrational number is represented by infinite decimal and not recurring decimal. No repeated decimal. Recurring means repeated. We already learned it before in last year. Each irrational number lies between two rational numbers. Irrational numbers, the square root of positive rational numbers which are not perfect squares, are not rational numbers, or they are irrational numbers. For example, square root 5. We don't have any number for power 2 to give me 5. Then square root of 5 is an irrational number. Square root of 3 also irrational number. Square root 6 also irrational number. The cube root, the other type of irrational number, the cube roots of rational numbers which are not perfect cube numbers. For example, cube number of 4. We don't have any number for power 3, give me 4. Cube root of -9 and cube root of 11. Pi is not a rational number because it's an approximated ratio, not exact ratio. From previous, there is another set of numbers which are not rational. It is called the set of irrational numbers and it's denoted by Q dash. And it's denoted by Q dash. Another example. Find the two consecutive integers for each of the following numbers to be included between them. He asked me to find two consecutive integers. What is the meaning of consecutive integers? Like 3, 4, 5 and 6, 7 and 8, following integer, consecutive. He asked me two consecutive included root 5 between them. First, for root 5. First, write the perfect square number. Why perfect square number? Because he asked about square root. So we need to write the perfect square numbers. Our perfect square numbers, 1, 4, 9, 16, 25, and so on. Search for 5. 5 lying between 4 and 9. Then root 5 lying between root 4 and root 9. Again, another type. 5 lying between 4 and 9. But he asked about root 5 to take square root for each number. Then root 5 lying between root 4 and root 9. Root 5 more than root 4 and less than root 9. Then root 4 equal to root 9 equal 3. Then root 5 more than 2 and less than 3. Then the consecutive numbers included root 5 between them are 2 and 3. Also for 12. Let us try for 12. 12 lying between 9 and 16, but we need the square root. Then square root 12 lying between square root of 16 and square root 9. Root 12 more than root 9, less than root 16. Root 9 equal 3. Root 16 equal 4. Then square root of 12 more than 3 and less than 4. That means 3 and 4, two consecutive integers included square root of 12 between them. The last one, the cube root of 10. We have to write the perfect cube numbers. Our perfect cube numbers, 1, 8, 27, 64, and 1, 25. Now, search for cube root of 10. 10 lies between 8 and 27. Then, cube root of 10 between 8, cube root of 8 and the cube root of 27. Again, another time. 10 lie between 8 and 27. Then, cube root of 8 less than cube root of 10 less than cube root of 27. Cube root of 8 is 2 and cube root of 27 is 3. Then cube root of 10 more than 2 and less than 3. That means our two consecutive integers included cube root of 10 between them are 2 and 3. Thank you.